Hello and welcome back. In this video we'll be discussing the last section in chapter 7, and that is synthetic strategies. Now we'll look at this again in chapter 11 where we study synthetic strategies specifically, but we want to bring this to your attention early on so you can get an idea of why you're learning all of this. Alkyl halides are some of the most important compounds available. Not only are they found in nature, most of them are made from crude oil, which is cheap and easily accessible. They're made from crude oil by halogenation of these alkane byproducts of petroleum gas distillation. And so when you have a simple alkyl halide like this here in the middle, then from that you can make an alcohol, okay? You could make a tosylate where you can go on to make something else out of that. And you can then do an elimination to get an alkene. You could make an ether if you're reacting that alkyl halide with an alkoxide, right? You can get an ether. If our nucleophile is SH, you can make a thiol. So notice here, what I'm saying is, if I had OCH3 here, okay, then that could attack, kick out the bromine, and then I've got the ether. If I had, the SH here as my reagent, that can attack, kick out the bromine, then I've got a thiol. If I have this acetate group here, I can make an ester. If I have this cyano group, I can make a nitrile. So just by swapping my nucleophile, I can make many different things in organic chemistry. And this is very important. So in order to figure out how to make what we want, we start by, looking at our product and saying, how can I get here? Okay, how can I get here? So by remembering all of the reactions that we've learned, then you can learn how to get to your products. So I highly recommend that you make flashcards when learning these reactions, and make your own flashcards rather than buying some, because these reactions may be specific to our book. I mean, most of these reactions are common to all organic chemistry books, but every book is going to be just a little bit different. And so you're going to learn specific reactions to our book. It'll be more helpful and you won't be wasting your time. Okay, so if we have a tertiary alkyl halide, then that can be made from an alcohol, okay, or you could make an alcohol if you react it with water. And I don't want you to try to memorize all of this stuff, but you do need to memorize the reactions overall. You can make an alkene if you use concentrated sulfuric acid. You can make a tosylate from your alcohol here. We've learned all of these reactions. We can get an alkene. That's our Zaitsev product or our Hoffman product, depending on what base we use, if we use a base. So all of these synthetic strategies can help us to develop a product that we want. So if you're building a house, then you want to imagine what the house will look like. Maybe hire an architect and figure out what you want your house to look like, and then you call in the builders to help you build it, but you've already got a plan. So an organic chemist is an architect that helps to build these molecules, to help design a plan for the molecules. And this is to look at our product and then figure out a pathway to get there. It's called retrosynthetic analysis. It means that we're going to look at things in reverse in order to get to what we want to make. So in other words, if we want to make this ether, then we draw this retrosynthetic arrow, which means we're going backwards. This open arrow means we're going backwards, okay? And so we can make that ether from an alkyl halide and this alkoxide. So the OET, remember ET is CH2CH3. Okay, so the OET is going to attack here, kick out the leaving group, and that will give us our product, okay? So we look at the target molecule. This is called our target molecule. We can abbreviate that TM to figure out how to get there. Okay, so in order to, so let's go back. So in order to make this ether by breaking this bond here, we would use this alkyl halide and this alkoxide. But we could even make that ether by breaking this bond over here by using this alkoxide and this alkyl halide. So now the left one has become our nucleophile, right? And the right one has become our electrophile. So this is attacking here, kicking out the leaving group, giving us the same alkoxide. How would we decide what we wanted? We'll probably go to the stockroom and see what we already have paid for, right? Just to see what's more readily available. So we want to make sure that it also is reasonable. So a primary alkyl halide works with a good unhindered nucleophile for SN2. Okay, and so this would probably work pretty well. So once you're done thinking about it, then you can draw it in the forward reaction. So we draw our starting material, react it with our alkoxide, and in this case we have a polar aprotic solvent, which is DMSO, and we get our product. Okay, so how would we make something like this? Okay, well, we've got, and using the knowledge that we know, there are actually a couple of different ways to do this, but using the knowledge that we know, we've got this ethyl acetate. That's what this is, and this is called an acetate species here. This is an ethyl group over here. Okay, so we know, so looking at this retrosynthetically, we know that acetate is one of our nucleophiles. So we could use sodium acetate plus an alkyl halide, like this bromide. So if we wanted to do this reaction, will this work? This acetate attacks here, kicks out the leaving group, and this is not hindered, so this should work just fine. So then if we want to draw this reaction going forward, we take our electrophile, which is the bromine, and we take our acetate, which is the nucleophile, and we draw the forward reaction to give us our product, which is also called the target molecule. So this was just a short introduction to synthesis, and we'll see a lot more of this in chapter 11. Thanks for watching. I'll see you in the next chapter.